In this video, we're going to create a test bench file for the n-bit UpCounter. So first, let's create a new Verilog file and save it as test bench n-bit UpCounter. Save. And then what we can do now, we can use the test bench for ring counter with just simple modification. So we need to change the name of the file is test bench n-bit UpCounter. And then we need to import our module name. So it is the n-bit UpCounter. And then in n-bit UpCounter we have clock, control, and reset. So we have clock, test bench clock, and then we have control. So test bench control, and then we have reset, and then we need to declare them here. So we have control, and then we have reset, and then we want to count. For example, we want to test to count from 0 to 15, and then in the rest clocks we will generate a random inputs for control and reset to see how the functions that we have implemented here works. So what we can do now here, it is to count, for example, for 1 to 15. So we need to, in the first clock, what we need to do, we need to reset the counter to 0 to initialize it. And then what we can do next is to disable the reset. So to 0, and then we need to enable the control to be 1, for the rest of the 15 clock. And then it will count from 0 to 15 since the enable is high and the reset is low. And then what we can do next is just to create randoms input for the reset and for the control. So random, and then it is 2-bit. Then we need to do the same here. Now the counter will count from 0 to 15, and then in the rest of the 15 clock it will just generate random inputs of the control and the reset. So this is 30 clocks, so times 4, I think it's going to be, let's say 130 simulation time, and let's save it and try to analyze and synthesize to see if you've done everything correctly. And then we see that we have no error. So let us launch the module sim. And let's compile our design. So it is test bench UpCounter and UpCounter. And then simulate. So add to wave. So change simulation to nanosecond and run all. No. And then let's change to unsigned numbers. Now we can see our simulation run up to 130 nanosecond, and it counts from 0. So in the first clock here, we can see that we initialize our counter, so it's 0 in the next clock, and then it will start to count up from 1 to 15, and then after 15, the rest of 15 clock will generate a randoms input of control and reset. So for example, we can see here after the 15 clock the control is 0, so it's not high, then the counter will not count, and then it reset here, and then you can see the only place it counts from 1, 2, and then it reset again, 1, 2, 3, it reset again. So this UpCounter work as we have designed. In the next video, we will try to implement this UpCounter ring counter and register to our neuron core.